Chapter 7, Review Part 2. Section 7.3, the normal distribution. Lesson objective: find and interpret the area under a normal curve. Now before we begin, let's recall the standard normal distribution. In our last video, we used the standard normal distribution to find area or probability under the standard normal curve. The mean is 0 and the standard deviation is 1 for standard normal distribution. Let's introduce some notation for finding the probability using the standard normal curve. This notation here means the probability of z being in between a and b. This notation means the probability that a z is greater than a. And this notation means what is the probability of a z being less than a. Okay, let's look at some pictures. So this notation, the probability of z is greater than a, would correspond to this picture. Here is a, and we're wanting the area greater than a. The next one, this is read the probability of z is less than a. This is the corresponding picture. Here's a, and this is the area or the probability less than. And the last one, this is the probability that z is in between a and b. And here's the corresponding picture. Here's a, here's b, and this is the area in between a and b. Let's do an example. Find each of the following probabilities. A, the probability z is less than negative 0.23. B, probability z is greater than 1.93. C, the probability that z is between 0.65 and 2.10. And D, the probability that z is in between negative 2.33 and 3.99. So you can pause this video, try these four, and then we'll go over the answers. Okay, looking at A, you should draw your picture. We want less than negative 0.23, so we look this up in Table 5, and we see that the answer is 0.4090. B, we want the probability that z is greater than 1.93, so we have to do 1 minus what's in the table, and you end up with 0.0268. C, this is an in-between, so we look up this z, write that probability down, and look up this z, write that probability down, and then we take the larger area minus the smaller area, and we end up with 0.2399. The last one, same idea. This time we have to use the default. 3.99 is larger than 3.49, so we use the default 0.9999, and we subtract that from the area to the left of negative 2.33, and we end up with 0.99. Now let's go to lesson objective number 1. If we want to find the area under any normal distribution, these are the steps that we do. The first step, we draw the picture and we shade in the desired area. Second step, we convert the values of x to the z-score using the z-score formula. Third step, we draw the standard normal curve and we shade in the desired area. And step 4, we find the area under standard normal curve, just like we did in the last video. This area is equal to the area under the normal curve. So here's our original distribution. Its mean is mu and standard deviation sigma, and the z-score standardize all the values to the standard normal curve. Therefore we can use Table 5 to find the area. This area under the standard normal curve will be equal to this area of the original population. Let's look at an example. A psychologist is designing an experiment to test the effectiveness of a new training program for airport security screeners. She wants to begin with a homogeneous group of subjects having an IQ score between 90 and 120. Given that IQ scores are normally distributed with a mean of 100 and a standard deviation of 16, What percentage of people have an IQ score between 90 and 120? Our first step is to draw a picture. Here's 90, there's 120, and we have a mean of 100. Now this is an in-between problem, so we have to convert this to a z-score and the 120 to a z-score. The first z-score, 90, minus the mean divided by standard deviation, gives us a z-score of negative 0.63. The second z-score, 120, minus our mean divided by the standard deviation, gives us a z-score of 1.25. Now to find the area in between, we look up the area to the left of 1.25, write that probability down. We look up the area to the left of a negative 0.63, write that probability down, and subtract the two probabilities, and we end up with 0.6301. So to answer the question, the percentage of IQ scores between 90 and 120 is about 63%. In this slide, here's some common terms for math symbols. At least is the same thing as saying greater than or equal to. More than is the same thing as saying greater than. Fewer than is the same thing saying less than. No more or at most is the same thing as saying less than or equal to. Using standard normal distribution, this is the same thing as greater than. Less than or equal to is the same thing as less than. Important phrase that we need to remember would be at least, which means greater than, and also at most, which means less than. Let's try some examples. What is the proportion of the population who have at least an IQ score of 132? First thing that we need to realize is at least means greater than. So we draw our picture. The mean is 100. Here we have our x, 132, and at least means greater than. So from the picture we see that this is less than 0.5. Our next step is to change 132 to a z-score. This ends up being 2.00, and using table 5 we look up 2.00, and we have to subtract it from 1 because it's a greater than, and we see that the answer is 0.0228. Next example, what is the percent of the population who have an IQ score at most 95? At most means less than, so we draw our picture, means 100 and it's in the middle. 95 is below 100, and we're wanting the area to the left because we want at most, and that means less than. Next step, we change 95 to a z-score. Be sure to include the negative sign because 95 is less than the mean, so our z-score will be negative 0.31. Looking up in table 5, we see that the probability of the z being less than a negative 0.31 is 0.3783. What is the probability of having one person with an IQ score no more than 110? No more than 110 means less than, so we draw our picture. Mean is 100, it's in the middle. 110, and no more means less than. Next step, we change 110 to a z-score, 0.63. We look up 0.63 in table 5, and we see that the probability that z is less than 0.63 is 0.7357. And this agrees with our picture. Our picture here, we knew that the answer had to be more than 0.5, and it is. Here's the readings and suggested problems. Thanks for watching.